Welcome to Wise Up on Air. I'm Damien Kaspauer, and today I'm joined by Philippe Milot. Hey, Philippe.
Hi.
Great to have you here talking about web audio today. We're going to go deep into what's been happening over these last years, where we are today, and what we're looking at for the future of web audio. But first, Philip, tell us a little bit about your role at Audiokinetic.
Yeah, I'm a programmer. I work in the core development team for Wise. I work a lot on the SDK side of things, and I've been working at AK since 2018. And in fact, 2018 is the first time I heard customers asking for web support, and it's been a steady incoming stream of requests to support the web since then. So
yeah, and we're going to dig into some of the reasons why that has been a process over these last years, and it's been so great to have you championing that effort since your arrival. You, of course, dabble in a lot of other things. We saw you at the Wise Worldwide Online Expo presenting on the 3D Audio Bed Mixer plugin.
that's right.
So,
Yeah.
thanks again for sharing your knowledge with the community about that. For folks out there who are authoring object-based audio since 21.1, that plugin helped to give just a little more control over how folks do that. So nice work on that. And great to have you here today. So you want to give us a high level of what we're going to get into?
Yeah. So first, I'll explain a bit what the web platform is for us from our point of view as a middleware developer. Then I'll go into what the work that's been done since 2019 and even before that, and just the road that we took to get to where we are today. I'll go into more technical details about why it took so long to get to where we are and what's so different about making a game for the web compared to other platforms like desktop PCs and game consoles, and even mobile.
Yeah.
And of course, we'll also leave time at the end for talking more about the future and where we think we're going and more about roadmap.
Cool. We're going to keep the tech preview you've got readied under wraps.
Yeah.
So stay tuned for that, because we've got something to show you and something to hear.
Yes.
Coming up, but stay tuned for that. If you have questions throughout the discussion today, feel free to drop them in the chat. Already good to see Mess in the chat hanging out as well. So drop your questions as we move through things, and we'll try to bring them to the live stream to get answered. So with that, I will hand it off to Philippe.
All right.
Let's roll.
Let's roll. So here's the thing. The first thing I should be explaining is what's the web platform for us from the point of view of middleware developers for games. So what does it take to make a game on the web? And we can do that by comparing it with other platforms. So let's start with that. The operating system and the environment. So when you want to make a game, obviously you need something to run the game on. So usually it implies some sort of hardware, like a game console or a PC, and also an operating system that gives you services that you need, like audio and video, so that you can make your game. The equivalent for the web is a little different, because the operating system environment is the browser itself. It's not hardware, it's software. It's an abstraction, basically. So when you make an application for the web, you will never interact directly with APIs that are on the host platform, whether that's a browser running on Windows or Mac. You will never access the Windows or Mac APIs directly. You will always access the services that the web gives you. And the reason for that is security. The web browser is it allows for a lot of different apps to run, but it needs to remain secure. So it will run every app in a sandbox and only allow it the appropriate APIs to make it work. So it's not as free for all as you would get on a normal operating system. And of course, when you want to write an application, you need some sort of software development kit. And usually the platform maker is the one giving you an SDK. So you have an SDK for the Nintendo Switch, you have an SDK for PlayStation, Windows. They're all SDKs. So, Damien, what do you think the SDK is for the web platform? And we're talking about C and C++ here, because we're in the realm of game development. Obviously, you can develop apps on other languages, but here we're sticking with C, C++.
Is it HTML5?
It is not.
Is it CSS? I'm just saying acronyms now.
It's a project called MScripton, which is an open source project. And basically, it will give you a C++ API and a toolchain so that you can take C++ code and compile it down to an executable format that you can run on a web browser. And
so the web browser then, executes that and then presents it as part of a web. Exactly.
So you said execute that. So what is that? What is the executable format? See, that was a good segue, right?
Nice.
So yeah, what's the executable format? So in regular platforms, usually, and in fact, currently, all of the platforms that we support will either give us Intel x86 or ARM machine code when we compile. So those are what the SDK, the various platform SDKs output, basically. But for web, obviously, you cannot run machine code directly. So the equivalent of machine code for the web is something called WebAssembly. And it's another kind of binary format, but it's made specifically for the web, and it simulates some sort of virtual CPU that doesn't really exist, but it's a CPU that the web browser will emulate, and it's made for real-time applications.
Yeah.
So it's
not the same as a virtual machine.
It's not quite a virtual machine, because a virtual machine also implies services and like doing virtualized video and audio.
Right.
But just the CPU architecture is virtualized. It runs in a sort of VM. Yeah.
Perfect. Thanks.
And yeah, you could also argue that I should put JavaScript here, because that's technically another executable format that the web supports natively. But there are real problems with just making games in JavaScript, because you're tied to a garbage collector, and it's not suitable for real-time applications. If you want to do stuff that's real-time, you need to use WebAssembly. There's no question, because otherwise you will be fighting the garbage collector that can interrupt your application at some point without you knowing about it, and just cause you to drop a video or an audio frame. So WebAssembly is really the right thing to use for games.
That's an aggressive garbage collector.
Yeah, well, all garbage collectors are like that, unfortunately. And the last thing is, usually you have a distribution method to take your game that is in the executable format and the assets, the textures and the 3D models and stuff like that, and the audio, and you need to distribute that. So, Damien, what do you think it is for the web?
Is it a present? Is it a box of cheese? Is it a... No, I don't know.
Okay. So, you know it. It's a HTTP.
Aha.
Web server is the method you will use to actually send down your assets and your executable code to the browser of every user that you want to have the game run on.
Gotcha. So that's the distribution method, and we package something up and allow access to it through that method.
Exactly.
Got it.
So it's a real platform. It's like in a way it ticks all the boxes, and it's a real platform. So that's why we want to support it. Unfortunately, if we look at the operating system environment in more detail, we will see that the web is actually quite different. So any operating system environment, especially those that want to support games, are going to have to offer some kind of audio, graphics, input APIs, something to store files on. Usually you need networking and coordination, concurrency. And there are equivalences for every one of these for the web, but I've highlighted in orange those that do not fully translate to they're abstractions that don't fully match what normal platforms support. And it's the crux of what we're going to talk about today. It's the fact that those are not perfect abstractions that make it so hard to create games on the web, and why it took us so long to get to where we are today.
And some of those things, some of those equivalencies have been, expanding and evolving over the course of, the evolution of the web. So web audio as a standard, of course, is something that, is continually evolving and growing. So this is part of what you've seen over time, I'm sure.
That's right. So the web works a bit differently than other platforms in that everything needs to be specified, right? There needs to be a spec because there are many browser makers. So you don't have just one implementation of the platform. Every browser maker makes a different implementation of the web platform.
Yeah, and meanwhile, they're all working together to drive the feature set of that platform.
That's right. There are working groups with representatives from each browser maker. We're part of the web audio working group, the community working group. And so you have these browser makers working together, and often what happens is they're going to implement features in their proprietary browsers first, and then try to get it ratified as an official spec. So sometimes you have features that come out in a browser and they're not official yet, but you can use them just to like, it's basically a tech preview in a way.
Yeah, you're jumping onto like an experimental version of Chrome or Firefox or whatever you're using, and they'll publish that with a feature that's not quite ready for prime time, and you're saying that that's part of how they work through how things will eventually arrive to something like a web audio spec or a spec across browsers.
Yeah. So actually, this is a good time to talk about that because we have an actual good example of that. The web audio spec first started out its life as a Chrome implementation. And so for a long time, it was only available in Chrome, and particularly a part of the web audio spec, which was instrumental for us, which is called the audio worklet. And this part of the spec is the one feature that we needed to really get a working sound engine on the web. And for a long time, this was only supported on Chrome. And it's one of the reasons why we held back, basically. So in 2019, we actually had a prototype of our integration demo. You can see it here, which we actually showed publicly at a workshop in Seattle that was organized by the W3C. It was the workshop on web games. And we showed this, and we explained a bit like the roadblocks that we had in making this. And in the end, it only worked in Google Chrome because Audio Worklet was only available in Google Chrome at the time. And we put the project on ice because this came at a time where I don't know if you remember this, but this was a few years ago. But there were security attacks done on web browser called Spectre and Meltdown. It wasn't unique to web browser, but there were faults in the CPU, and so they had browser makers had to take measures to protect themselves against those attacks, those Spectre and Meltdown attacks. And one of the things they did was disable a feature called shared array buffer, which I will explain a bit more in detail what it's used for later. But this was actually needed for our prototype to run. So the fact that browsers decided to disable it, we basically said, okay, it's not the right time to to invest in this. Let's wait and see what happens. Smart. And they figured it out eventually. They found a way to re-enable shared array buffer in a more secure context, and now it's available again. So we picked back up the development. Also, in the meantime, Firefox started to support the audio worklet part of the spec. In fact, they have full support for the entire spec now. Nice. So we have the two major browsers supporting web audio. So we decided to give it another go this year and actually push forward much more deeply and try to have a real game run, like not just a tech demo, but actually have a real world use case.
Right.
So this means compatibility with Unity, because Unity is one of the major game engine that actually supports exporting to the web. We also found a way to allow for downloading assets as the game is playing, instead of requiring users to download the entire audio assets up front before the game starts. So right. That's a big win for usability. We added Wwise profiler support, and it's basically part of the build, the daily build of Wwise. Now web is a platform there, and it's actually in 22.1.
Right.
However,
and what you were saying, having an actual game to test it with, it's not just a sound or a small subset of sounds. You're talking about like the full scale, like music, sound, voice, like.
That's right. So we were able to get the entire sound engine working, compiled down to WebAssembly, basically. So everything that was computed in software basically works on the web. So all of our software effects, all of our decoders that are software, they all work. So that was a big win. However, if you start the launcher now and you download 22.1, you will not see the web platform in your launcher, and that's because it's available as a tech preview, right. Which means that if you want to have access to it, you're going to need to contact our sales team, and they can just flip a switch on our side, so that to give access to the web preview for your user account.
So you heard him. You can contact business development to get that flipped on, but stick around here because we're going to give you some things to think about as you begin to investigate exploring web audio in its current form. So don't reach out quite yet.
Yes. So it's a bit of a paradox, this talk, because in a way my goal is to get people on board as much as possible, and to get feedback and stuff like that. But also, I do want to scare you a bit and be very clear that this is not production ready. It is not.
Okay, before we move on, there's a question coming in the chat, and I just want to give a shout out to Prashant, who's joined us as well. But 9 Points is asking, he's curious about the relative performance between native execution and WASM execution. Thoughts on that?
This is very hard to compare. You can have artificial benchmarks that can test that. Of course, you would need to run it on the same actual computer. It also depends on which browser you are using, because the WebAssembly is not native code. It gets compiled down to native code by the browser, so it depends on which browser you are using. One thing that a lot of people do wrong is that sometimes they benchmark WebAssembly, but they also benchmark it using JavaScript to call into WebAssembly. But the hopping from JavaScript to WebAssembly is actually the big cost in CPU performance. But if you're just staying in the WebAssembly realm, it's actually quite fast. But it's not the same. And we'll actually get into this in the talk a bit later. But as far as CPU performance goes, your main challenge is going to be threading. And we'll get into that a bit later. But the fact that threading works so differently on the web is a real challenge and will cause constraints on your CPU usage. So
cool.
In a real project, like, you will need to modify things in your Wwise project for the web platform specifically, maybe to save up on CPU just for that.
Yeah, and that's one of the reasons we have those platform overrides built into the software across properties, so you can make those platform-dependent decisions to optimize across all of your different, all the different places you're building your game.
Yep. That's actually a lever that you use a lot when you port to the web.
Yeah. Cool. I'm going to pin the next question from 9 Points, and thanks for feeding us these. I'll circle back to it when we get a little bit deeper into things. So thanks, and keep riding with us.
Yeah. So that's what's in 22.1. Like I said, it's not production ready. It's just a tech preview, just to get an idea of what people need out of our support for the web platform. And the next major release, we're hoping, will actually stabilize the preview to a point where we can actually say we support web in an official capacity, and bring in, like, all of our automated testing that we do on all of our other platforms. Just bring web into that and make sure that all of our tests run and execute correctly. So it's just making it production ready. All right. So how do you get started? Like I said, you will need an Audiokinetic account with an access to the web preview. So you need to ask the sales team. It's free for evaluation, just like any other platform. So just like you don't need to pay for that.
And we've got a link to the contact for sales, and Mike Drummelsmith is in the chat right now, adding more specificity to that. So
awesome. So you will need Wwise 22.1. If you want to target, if you want to integrate into a Unity project, at minimum you need to download the Windows, macOS, and web SDK targets. And if you're using Unity, you need to be using 21.3 or above. WebGL is supported in previous versions of Unity, but we had problems using previous versions. 21.3 was the one where the tool chain that comes with it is actually stable enough to actually get a good game out.
Yeah, and it kind of sounds like, across the spectrum of the industry, everyone is continually pushing this forward. This is really one of the edges of our industry as we continue to find a way to enable these experiences across the web. So,
Yep.
yeah, always makes sense to be right up on the edge when it comes to web audio, it sounds like.
Yeah, absolutely. Once you have this, you probably have a Wwise project already for your game. So what you need to do once you have the access to the web platform, you will need to do something in your local installation of Wwise just to enable the web platform in Wwise authoring. And all of this is explained very well in the offline documentation. So when you have your version of Wwise installed through the launcher, you can just go to the MScripton documentation and go down to web-specific information here. And if you want to try the web preview, you should read this entire page very carefully. This is this is your FAQ. All of the roadblocks you will encounter will be described here probably. So this is very important. And the first one is it will tell you how to enable the web platform in Wwise authoring. So just use that to just follow the steps there. And then once you have this, you can open up your Wwise project and add the web platform. You can copy the settings from any of your desktop platforms. You will have to disable streaming for sounds and music tracks. That is the big problem that we have with the tech preview right now, is that we have no support for actual streaming from a web server. So this means that for every sound that we play, the sound needs to be fully downloaded before it can start playing. So this means disabling streaming for sounds and music tracks. So obviously don't do this for every one of your platforms. Use that little lever that Damien talked about, unlink for the web, and just disable streaming there. And finally, the big recommendation I would do is go over your conversion settings and make sure that they're optimized for media size. The biggest roadblock to a web game is probably the wait for downloading. So it's more important to have a smaller download than to have higher quality for the web.
And is that a case of like, when you say that, is it like the one-time cost of downloading it is more manageable when that size is smaller, or is it across, I don't know, across the play session where you'll continue to cause, I don't know, repercussions because of those sizes?
So if you use the workflow that we're using for the Wwise Adventure game, you will be piggybacking on top of the Unity asset management system, and the Unity asset management system manages the caching of the files locally, so that they only get downloaded once when the user first plays the game. And even if you shut down the computer and come back later on the same browser, the assets will still be there in your cache.
Gotcha.
So this is we wrote none of that code. It's just Unity doing its thing, basically.
Yeah. But I love your suggestion here of using generators, so synthesis or
Yes.
other audio source input types. again, there's been a ton of great work done in games, leveraging the synthesis tools in Wwise to make hugely dynamic and expressive soundtracks with very little resources.
That's right.
Something that runs deep in the DNA of game development and game audio for sure. So a good
And you know what?
Start.
MIDI music. That's a really good case for MIDI music, just running on the web. And we do support that natively, so
yeah, absolutely. And we think about the web platform as still, or at least the web audio platform is still quite in its infancy, right? So if we imagine that similarly to the console infancy, right? Like what techniques would you leverage there? How would you do things differently in order to optimize the resources that you have?
yes, it's somewhat of a lost art, like working with a very constrained platform like they used to do. When I say they because I wasn't around that time, but when they wrote games for the Nintendo and like those very constrained 8-bit, 16-bit platforms, yeah, definitely you had to be creative.
Yeah, well, and even mobile, like the emergence of the mobile platform at one point drove the industry back to those fundamentals as well. So
That's right.
hopefully it wasn't too long ago and we still got some tricks up our sleeve.
Yeah.
Cool.
So once your Wwise project is ready, you can open up Unity. Actually, no, before that, you need to reintegrate Wwise into your Unity project because you downloaded the web platform, but it's not integrated into your Unity project. So you need to use the modify in Wwise functionality just to reintegrate that. And you will need, if you're not already using the Wwise addressables package for Unity, this is what we're using to download the assets from an HTTP server. So if you don't want to use the Wwise addressables package, you will need to manage your downloads yourself in your game code, basically. But and it's a valid choice if you don't want to use that. But the easiest thing to do is definitely to use Wwise addressables. And of course, you basically need to make your entire game work with the addressables package, which means you need to use the AK bank component. Like if you have code that calls load bank manually, programmatically, Wwise addressables is not able to hook into that. So you need to use the AK bank component. In the project settings, there's a few tweaks you should probably do. Like, for example, increase the buffer size, which is defaults to 512, I believe now. Double that, and you will understand why when we get into CPU performance and threading issues. And of course, you should render during focus loss so that you can use the Wwise profiler. And another recommendation is to create an addressables group for each one of your banks. And this will allow individual downloads of each bank. So I think at this time, we should probably show stuff. And this is the little surprise. You can just punch this in your browser and try it yourself. That's the beauty of the web. So we ported the Wwise Adventure game to the web, and it's available at this URL. I will open it up myself so I can show you around a bit.
Cool. I put that in the chat for folks who want to jump in and give it a try as well. I mean, you teased it there on the way to this moment, but having the Wwise Adventure game running in the web is pretty cool.
So here it is. It's the same one that you're used to. And it works in Chrome and Firefox, and actually, Microsoft Edge should also work because it's basically Chrome. It does. We have problems in Safari, and so don't try it on Safari. I think it's because we're using instructions in the WebAssembly code that is not supported on Safari yet, so it just gives an error when it starts. And also, don't try it on mobile phones. The Unity WebGL export does not support mobile devices, so it's strictly for desktop. So those are the requirements. Other than that, it's just the same game. We have the exact same stuff. Even spatial audio works.
Great.
And yeah, it's just the same game. As you can see, we also have sometimes a bit of difficulty with the input of the mouse. I actually tried to fix this morning, but it turns out to be a bug in Unity. So sorry, I can't do anything about that. But sometimes the camera will just start spinning around. Just hit escape and it will fix itself.
Cool.
Yeah. So that's it. That's a game. You can play around with it yourself, but I will just stop it here and just explain a bit why it was so damn hard to get this thing up and running and why it took so long.
Great. And for folks who aren't familiar, the Wwise Adventure game is, a fully playable game that leverages many of the features in Wwise. We have a series of certifications that step you through the process of building it. The entire Unity source is available through the Audiokinetic launcher, and along with the Wwise project and source audio files. So everything you would need to recreate the Wwise Adventure game is available to access, along with this documentation and certification for building it by hand.
Yeah.
Great.
Okay, so let's talk about threads. So like I mentioned, some abstractions for the web are leaky in a way. They don't translate fully from from a native normal environment to the web. And one of these is the threads and processes model that we have on every other platform that we support. So that's Windows, PlayStation, or every other platform. So normally what you have is a collection of processes running on the operating system. It's a multitasking operating system, so you can have multiple processes running at the same time. Each one of these processes has its own chunk of memory that is allocated to it, and another process is not allowed to peek into the memory of another process. So this is all segmented off. But inside a process, you can create multiple threads of execution. So stuff inside the process can execute concurrently. And all of these threads inside the process have access to the same memory, chunk of memory that the process has. There's no security implications there because all the threads are owned by the process. They can all see the memory. If a process needs to communicate with another process, they do so through what we call inter-process communication. And that's usually pretty slow, but at least it's possible. On the web, it works quite differently. By default, you only have one environment, which is the browser window, basically, and there's only one thread running on this environment. It's the main thread, and the main thread is used for everything for rendering the web page. So all of the JavaScript that you write for a web page that runs inside a web page runs in that main thread. the rendering of the visuals of the web page is also done on the main thread. Handling clicks and other user inputs is also done on the main thread, which means that, for example, if you have a bug in your JavaScript code that runs into an infinite loop, you're going to freeze the entire page and it will not render and it will not respond. Surely this has happened to you at some point in your life where the page just does not answer at all and it just goes blank a bit. So this is a consequence of the threading model of the web. You have one thread. JavaScript is designed to be single-threaded. And of course, this JavaScript environment also has like a big chunk of memory that it can allocate and free from. And it's managed by a garbage allocator. Obviously, at some point, developers started asking for, please, God, help us run stuff concurrently. Like, I need more than one thread. So for many implications, both technical and security, the solution that they came up with is quite different from the other model that we saw before. So they came up with the idea of web workers. A web worker works kind of like a full process in the other model. It has a separate memory. It cannot see the memory of the main thread. So it's not really a thread. It's like a separate process. But it does allow you to run stuff concurrently for real. The only thing you can do to make web workers and the browser window communicate with one another is through an API called PostMessage, which is pretty much the same thing as IPC on the other side. It's slow and it's not something that you're gonna want to do with real-time stuff. You don't want to do this often. So this is a problem because our sound engine is designed to use multiple threads inside one process, and it's designed so that all of the threads obviously can access the same memory, like all the sound, all the voices that are playing, all the buses that are instantiated. Any thread can actually consult this data and try to and look at the properties and peek into all that kind of data. So not having this one-to-one correspondence was a real blocker for us. Fortunately, in 2019, we ended up solving this problem by using something that MScripton offers. So you remember MScripton is the C++ SDK for compiling down C++ code to WebAssembly. And one of the things it offers is an abstraction of actual real threads on web workers. And it does this by using a very simple thing called shared array buffer. So I will explain how it works a bit. So when the application starts, MScripton is going to allocate many web workers. You can actually dictate how many web workers are allocated for your program. So for us, we needed like 5 or 6 web workers. So for integration demo, that's what we dictated. Every web worker is going to instantiate the same WebAssembly binary inside of its pseudo process, right? So they're all sectioned off, they're all siloed off. So all of them need to basically load up the game separately, right? But that still doesn't allow them to share the same memory. They just have the same executable code. It's like separate instances of the same game. But then there is something called shared array buffer, which is a browser feature. It's an API that allows you to allocate a large chunk of memory in JavaScript. And once you have this large chunk of memory, you can actually you can call explicit APIs to share it and expose it to multiple web workers, including and the browser window.
So you can put data into there and you can take it out across your different workers in order to exchange data and properties at runtime.
That's right. So MScripton, this is how MScripton does it. It will basically allocate a huge chunk of memory that is the entire heap that is accessible from the point of view of C++. Like all the memory that you access in C++ is inside this slab. And thread synchronization, like for example, if a thread needs to wait on another thread to finish its work, all of this is done through atomic operations on this slab. So it'll just flip a bit and say where I'm working, and the other thread is going to block until this bit is flipped. And this is how the same way that it works on every other native platform, basically. So it's a beautiful abstraction, actually. And so what's wrong with it? None of this is available in Unity. So need to start from scratch.
Okay.
So that's the main problem that we had, and why we abandoned the 2019 prototype, basically, because we went to port this over to Unity and we realized, well, A, they don't support it yet, and B, they don't look like they're going to support it soon because shared array buffer was temporarily disabled due to security concern, and there was this whole thing. So yeah, even today in 2022, none of this is available in Unity. So we needed to do something else to make the Wwise Adventure game work. So what did we do? This is our sound engine, a representation of the threads in our sound engine as it runs in other platforms, like in normal multi-threaded platforms. So you will have probably multiple threads doing external game work that we don't see. I just have one line here, but like it's probably many more lines. We have a bank. We have a thread dedicated to bank management, like reading banks and loading and unloading it. A thread dedicated to rendering the audio. That's obviously the biggest CPU, the one that eats the most CPU cycles. And another thread dedicated to reading and writing to files, and even another thread dedicated to just outputting data to the Wwise authoring when the profiler is connected, and just outputting to monitor errors and stuff like that. So we just couldn't make this work without the abstraction for that MScripton gave us, which is not available in Unity. So what we did was just compress this down to a single thread. So we developed an execution mode for the sound engine, which is just fully single threaded. So it works like the old model of the web, where you just have one browser window with one thread and everything runs on there. Just for maximum compatibility, we decided to offer this mode for the sound engine as well. And so this caused some challenges, because sometimes we had cases where the bank manager thread would wait on audio rendering to finish before doing an operation. Like, for example, when you say unload this bank, it's not going to actually rip it out of the memory if sounds are still using it, right? So it will stop every sound using the bank, wait for the sounds to finish, and then rip it out of the memory. So what do you do in this case when there's a single threaded sound engine? What you need to do is actually, when you run the bank manager part of the execution, if the bank manager needs to wait on audio rendering, instead of waiting, it will actually run another audio rendering pass, like in the same thread. Right. Just run this until all sounds are finished playing, and then continue with unloading the bank. So it's not perfect, and it's definitely not optimal like going back to the question we had earlier in the chat, this is the main blocker for CPU performance. It's not that WASM is so much slower than native. It's the fact that we only have one thread to work with, and this causes a lot of concerns about, like, what are you going to use your CPU cycles for? You don't have as many as you do on other platforms.
Right, right. I'm going to throw a quick link into the chat to a talk that we had here on Wise Up on Air a couple months ago, where we actually dug super deep into the CPU performance and multi-threading capabilities that have recently come out in Wise. We went super deep on it with David Crooks, and so I'm dropping that here in the chat. I'm wondering if you're ready to dance over a couple of questions here.
Yeah, sure.
We got 9 points holding it down with us here. Might have missed it, but can you invoke post message between web workers with a WASM context?
It's a bit complicated because, well, I mean, I'm not sure what you mean by WASM context exactly, but your question sounds like something that is unique to browser APIs. So what I would recommend is just going over to the MDN documentation and just look for the answer there. But for our use case, you have to remember that we're in C++ land. So while we can call out to JavaScript and use JavaScript APIs, post message is a JavaScript API, we only do this when strictly necessary. So in our case, we are using post message, for example, to share another slab of shared array buffer, just to this slab holds the final Wise output that is sent out to the sound card. Like, it's the one that the sync uses. So we're using post message for that. But so yeah, it's quite complicated. Just the gymnastics that you need to do in JavaScript just to get this thing working here, and the way that Unity generates the JavaScript for a WebGL project doesn't allow us to do any of that. So it's not really a problem of what the browser is capable of. It's what Unity will allow us to do with the generated JavaScript, basically. That's the best way I can describe the problem.
Cool. If there's any follow-up to that question, feed it in. I'm going to carry one more back to the chat from before from 9 points as well. Curious, how will you address lack of mutexes and other synchronization primitives outside of the atomic? And this is a good time to dig into it. We can. Otherwise, if it's better to postpone.
Very quickly, in the version that we have right now, we don't need to worry about synchronization because there's only a single thread. There's nothing to synchronize. So that's our answer for now. But we know it's not. It will not work for larger games. Like, it will only work for smaller games, and we're very well aware of that. And it's possible that other game engines will actually allow you to use multi-threading, because there's nothing in the browser preventing you from doing that. It's just a limitation of Unity. Cool. So if you're integrating into Godot or Default, for example, maybe you can actually use multi-threaded stuff. Mm-hmm. But then right now, the build that we offer for 22.1 is single-threaded. There's no way to have the multi-threaded version of the sound engine for the web right now. But for the next major release, we're really thinking about offering two versions of the binary. One for single-threaded game engines and one for game engines that allow multi-threading.
Great. Sounds like we're building forward towards multiple futures, and counting on folks to help us connect the dots as the platform continues to grow.
Yeah, absolutely.
Cool.
So I'm going to launch a development build of the Wwise Adventure game, just so I can show you in the Chrome profiler what the threading looks like. So it's basically the same thing I explained, but I can actually show it in the game itself, and actually show the drawback that it gives us. So on the right here, I have the JavaScript console. And so let's see. Okay. So I'm going to clear this, go to the performance tab, and actually use the Chrome profiler to record a CPU trace of a small chunk of time.
Cool. Great. So in those moments, it's dumping a bunch of stuff into a place where you can take a look at it.
Yep. Okay. All right. So I have about 9 or 10 seconds of CPU profiling, and so all of these vertical lines that you see are separate frames being computed, like game frames, and you can actually see the screenshot of every frame. It's actually a really cool profiler.
It's so cool.
And if you zoom in, you can see like this is a frame, this is a frame, this is a frame. So you can see that on average, it's around 0.18 millisecond. Like this is okay. And you can dig down into the actual functions that are being executed. Since this is a development build, I actually have the symbols, and Chrome is able to reason out the C++ function names. So we can see render audio and AK sound engine render audio here, and all in the Chrome profiler. So we can see here that this render audio took 2.81 millisecond. So the granularity of the traces at this level is not very. It's quite coarse. So these aren't real actual numbers. It's just the points that the CPU profiler inserts. There's basically a granularity involved that prevents us from knowing the exact timing of every function.
But that's still a pretty impressive level of detail that you're scaling there between,
It's a great tool to balance your CPU usage and stuff like that. And if I zoom out, you'll see that there's one here that looks quite different here.
Sure.
Okay, if I scroll back up, you'll see it's even red, and it says long task took 140 milliseconds. That is way too long. And the reason why it's red up until this point is because it missed the real-time deadline. So this frame took so long to compute that we missed the mark, and we weren't able to feed a new video frame at the right time.
Right.
And you can see why, actually. It's because so if I look at where this was happening, it's right when the push E to talk started to appear. And it's because in Unity, it was... Whoop, sorry. Where is it? Where's my large frame? There it is. So it was rendering and loading a font, basically. So just for this prompt.
Yeah.
But since there's only one thread, it means that loading this font caused the video frame to skip and also caused the audio to glitch, because you cannot run stuff concurrently. You can only run it on the single thread. So we actually had voice starvation, and I don't know if you heard it, but it actually had a small glitch. So this is why it's not production ready. This is the main reason why it's not. But it just goes to show that when you adapt your game for the web, especially in Unity or any other game engine that doesn't allow you to do multi-threading, you really need to worry about this stuff and make sure that all of your stuff is asynchronous and doesn't take too long to compute. Because in this case, it was not asynchronous. It just blocked until it was done.
And when you said load, so we're loading in that font, it's causing that hang. Is that a load from memory that's already been downloaded, or?
Probably, yeah. I don't know because these are internals to Unity.
Yeah,
but yeah, it's probably something like that.
Cool, yeah. So it's again, it gives you a level of granularity to be able to assess, but you'll need to dig in to find those optimization opportunities to smooth out those wrinkles with concurrency.
That's right. I'm gonna go quickly because we're running short on time. This is going fast.
We're doing great. You're doing a great job. So keep rolling.
Okay, so the other big challenge has to do with asset management. Like I mentioned earlier, you do need to use the Wwise Unity addressables right now to download stuff, to manage like the downloading of assets. And it's really not optimal because in the case of the web, you cannot have a download start. Like for example, you're in JavaScript land and you're sending an HTTP request to download a new sound or a new bank. You cannot wait for it to finish on the same frame. You absolutely need to start the download and just keep rendering your game until the download is finished, right? But even if you didn't care about that and you just I don't care if the download is gonna take 5 minutes, I'm just gonna block and wait 5 minutes and the game will just stop for 5 minutes. Okay, even if you do that, it will not work because the game the game that's waiting on the download needs to yield back to the browser so that the browser can run its rendering loop before the download can complete. So even if the download is finished, the browser will not let you know that it's finished until you yield back to the browser and try again on the next frame. So there's really no choice. You need fully asynchronous I/O to manage assets.
Right. It just keeps everything moving.
Yeah. So we don't have that in the sound engine right now. There are parts of the sound engine that do a blocking I/O call, and changing that is actually quite difficult and comes with a lot of risk. So for 22.1, we were not ready to go there. So what we're doing instead is piggybacking on the Unity system of addressables so that when we initiate the reading of a bank, it's already downloaded by Unity. So at the point where we perform the loading of a bank, we already know that it's in memory, so we never deal with HTTP downloads.
This is a kind of look ahead where in the game we know in advance, hey, in a couple minutes we're going to need this sound, so we're going to pull that down before we get there with enough time so that when that play action happens, everything's ready to roll.
And this is why we recommend using the Wwise addressables package for Unity, because this is the bridge that allows you to just declare that a scene uses a bank. And so when the scene loads in, it will just initiate the download right away, right?
Yeah, and especially when your assets are granular enough to be able to allow for, those smaller package sizes or smaller media sizes to be loaded and unloaded, you can really get that speed and optimization.
That's right. So in the Wwise Adventure game project, I did not change the way that the banks were structured, but I could have done more work to actually make the game, the banks even more granular, but I didn't do that. So these are the banks that we have, the different regions and the title screen, and we have some banks for the quests, right? So what I did, however, what I did do is in Unity, I use the addressables groups so that for the web, every bank has its own addressables group here. Because by default, when you integrate the Wwise addressables package for Unity, what it will do is create a single group that lumps all of your banks together. And it's basically just to get you going quickly. But what it will do is, for the web at least, it will create a huge initial download, and no sound is going to be able to play until this download is complete. So that's not what you want. What you want is to go down and actually split this into separate banks. And you can actually write scripts to do that automatically, but there wasn't that many banks, so I did it manually.
Yeah.
And
this
yeah,
this is just a fundamental of web or mobile development in general, and that's that, making sure that you only have loaded what you need to have loaded when you need it.
Yeah, that's right. So let's actually go back to the development version, so I can actually show you that in action. So what I'm gonna do is I'll go to the application and delete the local cache database that Unity uses, so that we start from scratch. Right? It's just like if I was loading up the game for the first time. And we're gonna go to the network tab so we can see what it actually tries to download. So I'm gonna reload, and you can see here it downloads the initial data. Gonna open this up a bit more. Yeah, so you have the WebGL.data is basically the graphics assets, I think, and you have here our Unity groups here. So the init bank is here, and the title screen bank, and now it's running. When I start the game, it starts to download the general and the first quest. It downloads village and pine forest because the camera is panning around this area, and then the woodlands. And as I advance the game, it just as I progress in the game, it will start downloading more of the assets, and this is all managed by the Wwise addressables package for Unity. So that's the idea. So this is kind of the approach that you need to take, is just try to make very small banks and make sure that they are only loaded in when the game actually requires them, and don't load them at the same frame that you post a sound, right? Do it a few seconds before, allow for smaller for slower connections and stuff like that.
Yeah, especially in the case of that initial bank, getting into the game as fast as possible, having the least amount of sound that you need ready, and then
exactly
hop, skip, and a jump on your way to, again, feeding in those tiny bundles of sound.
That's right. So that's asset management. One last thing I want to mention. One last challenge that we had. So there was a challenge about threading. There was a challenge about file system and just downloading assets. There was also a challenge with networking. And the challenge has to do with the Wwise profiler, because obviously this uses networking to communicate between authoring and the sound engine. And usually on most platforms, what we do is the game is going to open two ports So one UDP port and one TCP port. And then we'll actually have the authoring use the UDP broadcast to detect the games that are running on the local network. The game will answer, yes, I am here. Here's my TCP port. And then if you choose that in the little dialog, then it connects to the TCP port. Problem is, for security reasons, web pages cannot bind UDP or TCP ports. They cannot act as network servers. They can only act as clients.
Mm-hmm.
So what do we do with this? The solution for now is to introduce a middleman, basically. So we have a proxy server that we developed in Node.js, just a very quick prototype. And what it does is bind a WebSocket endpoint that the web page can connect to. And once it has a WebSocket client connected, then the proxy server acts as the game, basically. It will bind the UDP ports and the TCP ports because the proxy server is just a normal process, and it can do all of the things that we can do on other platforms.
Gotcha. And does that run outside of the game as a separate web page or separate application?
Well, it's a separate application. So so let's see here. I have right here. So in the installation directory of your Wwise install, you have SDK, samples, sound engine, MScripton, and there's a folder named Wwise Profiler Server. This is the proxy server that's here.
Got it.
So what you need to do is use Node.js to execute the server. It will start up a server. And then when the game starts, so I will put it here just to show you. When the game starts, it will try to connect locally to this server. And so you can see here, it's actually found the server. And at this point, then you can just hit up your Wwise authoring, open this, and you can actually see even the... One thing you need to do, this is very important, you need to keep this in the view, because if you don't have this in the view, the browser is not going to give you the CPU cycles to actually...
to keep it connected, yeah.
Yeah, exactly. So once you have it in the view, just hit refresh, and here discovery works. It's actually seeing the proxy server, but it doesn't know that it's a proxy server. It thinks it's a game.
Right.
So you can just connect to it, and then it works like any other platform. Like the profiler works. You have the voice graph. You can use the CPU profiler, which is another way of measuring your CPU.
Mm-hmm.
And yeah, the Wwise profiler just works.
And that proxy server will detect any Wwise web application that's active and in focus.
That's right.
Yeah.
So you can even have multiple instances running at the same time. Or maybe in your studio, you just have one proxy server running for everyone on the team, and everyone connects to it. It's all configurable in the settings.
Cool.
And then, so here, when I have two instances, normally it should be able to detect, see, I have two instances.
Cool.
So so this is what you're seeing here.
Yep.
It's, so let's close this. Yep.
Great.
So this is pretty much it.
Nice.
So it will just...
And of course, the Wwise profiler, connects the worlds of the game and what's happening on the Wwise side of things, and gives you where the profiler that you were using in Chrome that gave you that lens into the game engine and what was being executed there. Similarly, connecting the Wwise profiler gives you that picture of what's happening inside of Wwise.
Yeah, exactly.
Nice.
different profilers for different purposes.
That's right.
All right. So let's talk about the future a bit. I think
Cool.
we're done with my complaining and we can talk about the fun stuff now.
Cool.
So for the next major release, this is not final, obviously, and subject to lateness and delays and stuff like that. But the plan is to have a multi-threaded, well, actually to add back the multi-threaded prototype that we had back in 2019 as a separate binary for the, so we have two variants. We have a single threaded and a multi-threaded variant of the binaries for you to use, and you can decide which one you want to use based on the capabilities of your game engine. We want to support, like I said, fully asynchronous I/O, so that we can actually cut the requirement to use to manage assets from the game engine. So what would be really nice is if the I/O implementation that comes with the Wwise SDK itself downloads banks and caches them, and it's all done for you, and you don't need to integrate the Unity addressables in your project to have this working. So we're looking into that right now.
Cool.
The other thing we want to do is obviously remove the need to run a separate profiler proxy server, the little node thing that we talked about. So we're probably going to integrate that into Wwise Authoring itself. So it will just open up a WebSocket port for any web client, and web clients will just connect to it automatically.
Nice.
And like I mentioned at the beginning of the talk, basically making the project, the platform support production ready, adding automated tests, run the same battery of tests that we use for every platform.
Right. And for folks who are still with us or tuned in after, if you're still not afraid to jump into this wild frontier of web audio with Wwise, reach out to for an evaluation of the web audio platform. And part of that stability and quality control is getting feedback. So let us know how it goes. We will feed that back into the stability of things moving forward. So would value any insight you have. We have a bunch of different ways that you can get in touch with us, both through the creation of your project and requesting an evaluation, as well as feedback through the Audiokinetic launcher, either as reporting a bug. There's a survey attached to your Wwise version where we can receive feedback, and we're always taking feedback at openears@audiokinetic.com. So if you jump into the fray with us, let us know how it goes so that we can push that into the next full release and stabilize it for other folks who will follow.
And I mean, it's a fun fray to hop into. Like you saw the result, like just having to just being able to just share a URL and everyone tuning in can just load it up immediately. Like that's something that you don't get on any other platform, and it's really cool. It's really cool.
Right, and it's at the heart of that build it once and propagate it across, many, being able to share links between friends to prototypes, demos, games, and other fun things is a super accessible way to make games and to share those experiences.
Absolutely. So for even the farther future, there are things we're looking into that are more nicer to have stuff. So one of the things that came up, so earlier in the year, we went to the Web Audio Conference in France. I went there and gathered feedback from some people. I showed pretty much the same thing that we saw here, but it was conference from web developers. For web developers, and one of the feedback we got was, wouldn't it be nice to just have a JavaScript bindings for the Wwise API, so they don't need to whip up the MScripton SDK at all. They can just post events and load banks directly from a JavaScript application. So it's definitely something we're going to look into.
Cool.
It will enable a lot of different use cases that we're used to. We're going to look into 3D audio support, because actually part of the spec for web audio has a binauralizer built in. Like, it has a small node where you can feed signals, and we'll position them with HRTFs, filters, and so we could be building a 3D audio support based off of this feature. And finally, solve the not just the multi-threading part, but actually leverage, I didn't go into this much, but the audio worklet feature of web audio gives us a high priority thread that is designed to be used for audio rendering, but for the reasons I outlined with the Unity limitations, we couldn't use it. So we want to start using this high priority audio thread and take out the audio rendering from the main thread.
Nice.
And that's it. That's the web for us.
Well presented, and it's so cool to be here today with something that folks can, step up and give it a try, get us some feedback. Also great to see the future of this platform for Wwise. So thanks for that overview. I'm going to carry one question from the chat, and if other folks are listening and have questions, we can take them here. The question is, would it be possible to create an interface to play an instrument with, for example, JavaScript on a web page and use the Wwise audio engine with it? Or is it only possible with Unity WebGL? And that's from the Max Glitches.
Well, definitely anything that you can do in Unity WebGL, you can do with a native web application. Like Unity is bound by the limitations of the browser, so anything that Unity does, you can do with a web app. And so specifically for, I'm guessing, playing an instrument through MIDI and stuff like that. Definitely. There is actually another spec called WebMIDI, which gives you APIs to actually look at the MIDI devices that are installed on the host computer and actually interact with the MIDI devices. So you could actually write up an app that uses WebMIDI, takes the MIDI input, and sends it out through the MScripton SDK to Wwise and post MIDI events, and you can totally do that.
Cool. So and that's using MScripton as that bridge between
That's right.
between the web and Wwise, generally speaking. And the JavaScript side of that equation, that's more in that future bucket of building the Wwise API to access directly through JavaScript. Is that
that would be
fair?
one use case for this binding. It would make the writing such an application much easier.
Cool. And in the meantime, there's that MScripton piece that you can leverage in between.
That's right.
To get there faster. So I would love to hear about someone cooking that up with web audio and Wwise. So
Absolutely.
thanks for that question. Yeah. Wow. So awesome. Thanks for all of your work today, presenting this to the community, and in the past, your efforts to bring us to this point. Look forward to hearing more about it from the community. Let us know. Was this helpful? Was it meeting your expectations? Where do you see it going next? Always interested in getting these perspectives. So thanks so much for your time today, Philippe.
It was a pleasure.
Great. Well, and wishing you the best in this new year. Everyone out there, keep it easy, stay safe, enjoy these last days of the year. And this is it for Wise Up on Air in 22. We'll see you on the other side with more exciting things. In the meantime, enjoy your time.
Yeah. Happy holidays.
All right. Take care. See you soon.